focused on, if you saw it at the bottom of that slide, is the 80% by 2050 goal. We have a sort of an interim goal of 40% carbon reduction by 2030. What you'll see in a second is, clean heating and cooling is really important because heating and cooling buildings represents a significant portion, almost a third of New York State's carbon emissions. The only source of emissions that's higher is transportation. Obviously, NYSERDA is doing a lot to address transportation too, but our group was formed a few years ago to decarbonize the heating and cooling of buildings. Next. So this just reinforces what I was saying a second ago. About a third of the greenhouse gas emissions in New York State come from heating and cooling buildings. And the small pie chart, you can kind of see, for different sectors and different fuel types, how that breaks out. Next. And to drive the point home even more, if you look at residential, you look at single-family homes in New York, about 75% of the energy used in a New York home is for heating and cooling, including hot water. The average New York household pays about $2,500 a year in energy bills, so over $2,000 is for heating and cooling. Next. So the other thing that's driving us in the near term, or something new that's driving us, is the new Efficiency New York announcement and targets. So on Earth Day this year, the governor released a new Efficiency New York strategy that would basically end up being kind of like a midpoint toward 2030. And we're right now in the process of setting, formalizing, and fine-tuning targets for 2025. Heat pumps and beneficial electrification were included in that white paper that was released, with a goal of 100,000 heat pump installations in homes by 2025. And there's an order from the Public Services Commission that's expected soon that will formalize that and likely provide additional funding to help us get there. Next. So in terms of what our group has done, one of the first things we did was publish a policy framework in February of last year that sort of set the stage for short-term, mid-term, and long-term policy action on clean heating and cooling. What we did is look at, the framework had three pillars. We looked at how we could reduce technology costs and lower other barriers. High costs relevant to incumbent technologies is a key barrier for these technologies. We looked at policies to drive demand, and then we looked at incentives. And as a result of the policy framework, we were able to submit or as a follow-up to the policy framework, we submitted a clean heating and cooling investment plan to the Public Services Commission, which is how we get approval to fund things. It was for over $30 million, and it involved short-term incentive programs, community campaigns, technical assistance, workforce development, and marketing awareness and education, all of which I'll talk about in a little more detail now. Next. So as I mentioned, we looked at the barriers to clean heating and cooling. These barriers are actually pretty common across a lot of energy efficiency or renewable energy technologies. The first and probably one of the most important is that the costs and return on the additional investment above a standard heating and cooling system. The costs are higher and the return is insufficient for many customers. One of the things that's driving this insufficient return is that fossil fuel costs, especially natural gas, are extremely low. A lot of that's driven by the new gas resources that have been brought to the market through fracking. But there are a couple of other important barriers. That there's limited training available and limited quality installers, designers, architects, and engineers. And so educating them and giving them the skills to design and install these systems is really important. Customers, consumers don't know about these technologies. In some cases they do, and they have misconceptions, or they aren't aware of the progress that's been made in the technologies, in developing the technologies in the last few years. And in some cases, they're just not aware that the technologies even exist. And there's also a lack of affordable financing solutions. One of the things that was kind of a key to the early stage growth of the solar market was when the leasing models became available. That broadened the ability of a lot of consumers to be able to buy the technology. Next. So this is, I'm not going to spend much time on this. This is just a slide that sort of reinforces the low energy costs, the low fossil fuel costs. Next. So here are some of the things that we've done in the near term to address the barriers. And these are things that have launched since we got approval for that investment plan last year. We have an air source heat pump incentive program. It's about $11 million, and it pays $500 per condenser directly to the installers. I think this slide is a little out of date. I think we have about 215 participating installers now, which actually might be accurately reflected on the next slide. We also released a ground source heat pump rebate program. It's $15 million. That provides incentives to, the air source heat pump program is just for residential, single family and multifamily buildings. The ground source heat pump rebate is for all customer types. We launched our first 8 clean heating and cooling community campaigns this year, and are getting ready to select and launch another round. And we're also working with NYPA on a clean energy challenge to fund, to find, develop, and fund campus ground source heat pump projects. And I'll talk about all that stuff in a little more detail. Next. So here's a chart that summarizes NYSERDA's air source heat pump and ground source heat pump incentives. We also have a slide, I think that Michaela Ciovacco put together that summarizes the utility incentives, and we'll show that in a second, because several of the utilities are offering incentives for heat pumps now. But this goes in a little more detail on our programs. The ground source heat pump program, provides $1,500 per ton for small systems under 10 tons and $1,200 per cooling ton for systems above 10 tons. In all cases, the incentive goes to the contractor. In the case of the ground source heat pump program, the contractor is required to pass it along to the customer. And you can see some additional details here. Pat, are you able to bring up the utility incentive slide that John sent?
I will do that now.
Okay, thanks.
Might take just a second.
Yeah, so while you're doing that, I'll talk a little bit more about our incentives. We have committed just over a third of the incentives in the ground source heat pump program the last I checked, and I think about $4 million of the $11 million of the air source heat pump program, and so we have a significant amount of funding left, but the programs are through June 2019 for ground source heat pumps, although that might get extended, and through the end of 2020 for air source heat pumps, although it's while funding remains available. So thanks to Michaela Ciovacco, who put together this summary of incentives in the Capital District. And you can see the NYSERDA rebates that I was just talking about are listed there as the second line. Also note is that there's a federal tax credit for ground source heat pumps, 30% for residential, 10% for commercial. There's also some depreciation benefits for commercial customers. Recently, a few months ago, National Grid released a rebate that was approved in their rate case for residential customers. That's an additional $200 to $400 per ton. It's only available for customers who heat with fuel oil or propane, but it's additive to our incentive. So a customer can come in and get National Grid's and ours. NYSEG is working on a rebate. I'm not sure when that's going to come out, but probably sometime late in the year next year. And Central Hudson has a rate impact credit, acknowledging the fact that heat pump customers pay more than their neighbors for their electricity, or pay more than their fair share of the fixed costs of the utility service than their neighbors, and so they're providing a $264 per year rate impact credit for a couple of years. That was approved through a recent rate case. So for air source heat pumps, they're you can see our $500 per. It says per system. It's actually per outdoor unit, so we'll have to correct that on the next version of this. National Grid, again, came out with an incentive through their rate case. It's $200 to $375 per ton, with an $1,100 cap. Again, additive to ours. NYSEG has a current rebate through their efficiency programs, and so does Central Hudson. Those are both additive also to the NYSERDA incentive. And I think not the NYSEG is oh, I'm sorry, it's actually shown on here. The NYSEG's rebate is going to come out sometime early next year. It's not actually available right now. And then for heat pump hot water heaters, National Grid has a rebate of $300 per unit, and Central Hudson has a rebate of $125 or $750 per unit, depending on the capacity. Should also note that heat pump hot water heaters are eligible for the Home Performance with Energy Star program at NYSERDA. Thanks, Pat, and again, thanks to John and Michaela for sharing that.
Sure.
So if you move on to my next slide, Pat. So the other thing that we're really excited about and did earlier this year is we launched our first 8 clean heating and cooling community campaigns. These are kind of like solarized campaigns, so local community-based organizations, either municipalities or not-for-profit organizations, are choosing installer partners and then doing marketing and outreach to their communities to enroll residents, small businesses into their campaigns, where they're then matched up with an installer, and at the very least get transparent pricing, if not reduced pricing. And we have some incremental funding available for some of the campaigns to do additional work in low to moderate income households to sort of pilot new ideas for engaging those households in these types of campaigns. And we also have some additional funding for workforce development that we've made available. So you can see the 8 campaigns are listed here. You notice that there is not a campaign in the Capital District right now. We had a solicitation that was due for the second round of campaigns at the end of October, and we'll hopefully be making announcements about who received funding toward the end of the first quarter of next year. Next. So here's the map as it currently stands, and definitely if you're interested in learning more, most if not all of the campaigns have a website now. If not, they'll be launching one soon. And on the previous slide, not that you need to go back, Pat, but the previous slide has the organizations that are running the campaigns. And as I said, hopefully by this time next year, that map will be quite a bit fuller. Next. So we also have some technical and financial assistance that's available. As I mentioned earlier, we're running this $3.5 million clean energy challenge with NYPA. We screened somewhere around 100 commercial buildings, excuse me, and campuses, and about 20 or so are moving forward with more detailed feasibility studies, and hopefully those will develop into projects, which will then be available for NYSERDA incentives and NYPA financing. We have a team here at NYSERDA that does research and development, and one of their focus areas is on next-gen HVAC technology, essentially trying to move the technology forward in key areas. They put out these innovation challenges. They've done 2 of 4 so far, and you can see that heat pumps and related technology areas have been part of both the first and the second round. We also are working on financing solutions. We earlier this year made it easier for ground source heat pump projects to access Green Jobs, Green New York financing. Sometime around the first of the year, we'll do the same for air source heat pump projects. And we're also doing some market research to try to figure out how to develop some financing options like the solar leasing model that I mentioned, specifically for clean heating and cooling technologies. Next. I also mentioned we're doing some marketing awareness and education, which, as I mentioned, is a key barrier. So for our installers, their distributors, and their manufacturers, we have a cooperative advertising and training program on the street right now. There's $2 million is the total budget. I think maybe we've committed about $800,000 so far. Distributors and installers can get 50% cost sharing per year. 50% cost sharing up to $50,000 per year for advertising, marketing, and training. And then manufacturers can also get up to $50,000 per year for training. And we think that's we're excited about that program. I think it's a good benefit for our participating installers. We also are doing a lot around just general marketing. We have a pilot marketing and awareness campaign in Central Hudson's territory now, where we're doing billboards, print, digital. That's through the end of the year, and we're going to kind of measure the success of that, and then probably work with other utilities. National Grid might be next to roll something similar out in other areas. We developed a marketing toolkit for the community campaigns to use, and we're working with this company called Faraday to launch a customer targeting tool that'll help installers identify high potential clean heating and cooling customers. We have a beta version of that right now that's being tested by the community campaigns, and will be more broadly launched in the first quarter of next year. I also mentioned earlier that a lack of educated and qualified installers, designers, and engineers is an important barrier for us to address. So we're offering some funding to that cooperative training program I mentioned earlier. We also have done a number of trainings over the last year and a half or so, and are working on a comprehensive strategy for this technology area. What's needed, what things can NYSERDA or other market actors do to fill the future supply chain. Next. And then the final thing that I just wanted to mention, we're also doing pilot projects. We understand that there's a lack of information and a lack of confidence in the performance of the technology, and so to address that, we're doing about 90 residential installations across the state that are summarized here. Some, about 40 or so are ground source heat pumps, and the rest are air source heat pumps. Once we've done the installations, which we're probably close to about half, a little more than half of the projects are installed, then we'll measure the performance for a year, and then we'll publish the information to the market. And I think that was my last slide, Pat.
Terrific.
Thanks a lot
Thank you, Scott.
Yeah, thanks everybody for participating. Here's my contact information if you have any questions after the webinar.
Terrific. And again, we will be sending those slides around. Jack, I just unmuted you. Are you there?
Great. I am. Yes.
All right. Well, let me get your slides here for you. And just say next when you want me to advance.
Next. Well, thanks, Scott. I really enjoyed your presentation, although I would probably dispute some of the things that you said, but that's cool. This is a 40-year-old new technology, and what's interesting about it, this is pretty simple. It's caveman technology. It uses the Earth's thermal properties in conjunction with electricity to provide space conditioning and water heating, yada, yada, yada. It actually just provides comfort. Next. I think you skipped one, Pat. Or did you? This is interesting because I've been in this business for about 30 years, and I think that we've been climbing this hill for a long time. This is one of the interesting aspects of this technology, and actually any of the technology we're talking about now. If you look at this, 36% of the primary energy used in the U.S. is from energy used in buildings. This is more than energy than used in the transportation industry. But I dare anyone to let me know if they've seen a commercial on buildings on TV or advertised in the radio. All that we're talking about is cars. 40% of the energy used in those buildings is for what we're talking about right now, space conditioning and water heating. Next. I was the director of the Geothermal Heat Pump Consortium under Clinton and Bush, and this study was done by the U.S. EPA, and they designated geothermal heat pumps as the most energy and cost-efficient heating and cooling systems available today. They said this in 1996. I checked with them this year, and they're still saying it. They use less electricity, produce fewer emissions than conventional systems, reduce air and water pollution, provide a comfortable indoor environment for the building occupant. Having said that, next. This is what's really been interesting. I don't know whether anyone knew this or not, but the U.S. has spent $317 billion on natural disasters this year. I was in D.C. about a month ago meeting with both Democratic and Republican legislators, and rather than talk about climate change, global warming, sustainability, they settled on the fact that they were very interested in the fact that this technology using the ground to heat and cool the building is a resilient technology. Next, please. What has stifled this technology for this last 40 years is not the fact that it doesn't work. It's not the fact that it can't be used everywhere. It's the fact that it costs more money. And that barrier is what has been the first cost barrier, I believe, is one of the most striking barriers that has stifled this technology all along. What's happening right now and what I'm working on right now, and as you heard Scott in the last presentation, there's growing interest in this technology by utilities and third parties and investors as a non-traditional new business model. Now, when I talk about as a new business, I'm talking about the ground loop and not so much the heat pump itself. Utilities, especially in New York, are being mandated or urged by regulators and legislators to become more involved in distributed energy resources, DERs, and mandates such as with New York's REV program It allows utility owner rate of return when DERs are deployed. But when most people think about a distributed energy resource, it's always in terms of solar panels or wind turbines. What I'd like to point out is that there's another more attractive and abundant source of energy, and that is the earth. The same ground that stores solar energy, and that's the catalyst for geothermal heat pump technology. Next, please. What has changed? These states that you see on this slide, all men have designated the ground loop as a renewable thermal asset. This is a value to both a utility or a third-party investor whose participation in the loop ownership can remove that high cost, first cost. Remember, I said the loop is the high first cost. Next, please. I have a background. I worked for a utility for 34 years, and how I got into this business is the utility asked us to form a geothermal subsidiary back in 1985. In 1985, we owned everything. We owned the loop, we owned the inside. We did 115 projects, institutional projects, and was quite successful. What's coming about, everything old is new, is when the way utilities earn money in the past was through capital investments. Cost of service model typically returns 10%. They've had incentives to build new power plants, invest heavily in capital assets, et cetera, et cetera, et cetera. This technology, when I speak to utilities, I speak to it as a new way to do business. And it could be the key to the financial growth by investing in capital assets. The ground loops, they don't require huge capital investment, and they're guaranteed for 50 years. They probably last 100 years. Next, please. Why would a utility want to own this? Or a third-party investor? And believe me, I'm getting calls, and we're speaking to a number of both utilities and third-party investors that realize that this technology not only saves energy, it not only reduces emissions, and it not only provides jobs, but when we talk about an investment, levelized cost of energy for anything, for a utility, say, is how long that system or that asset can be amortized. A gas line averages 35 years. For a ground loop, it's 50 years. Next, please. We've always talked in the years that I've been doing this about the reduction of peak load. Now, the reduction of peak load has been verified that in a study done by Western Farmers, for every ton of capacity, it reduces peak load by 0.55 kW. I had forgotten I had done this when I was at the Geothermal Heat Pump Consortium, but I was interested to see how much energy we could take out of the ground. In other words, how much energy, remember, 3/4 of the energy that you're using in this technology is coming from the ground. Only 1/4 is coming from the utility. So I'd asked Dr. Marvin Smith at OSU, Oklahoma State University, which is, by the way, where the International Ground Source Heat Pump Association is housed. And I asked them to test the 4-ton system. As you can see by this slide, a 4-ton system in a 30-day period draws the equivalent of 4.5 megawatt hours. And part of our problem in our technology is we've always talked BTUs, and the rest of the world is talking kW. So what we're trying to do now is extrapolate this and speak the same way other renewables talk about, like solar, like wind. And so a 4-ton system in a residential unit would draw the equivalent of 4.5 megawatt hours of energy out, free energy out from the ground. Next slide, please. As you can see here, and we all know that utilities, both electric and gas, are being mandated by regulators, or in the case of co-ops, board members, to reduce peak load, lower emissions, invest in renewables and energy storage. What I've been saying all along is that GHPs, geothermal heat pumps, are a non-pipeline solution that's both that actually is using the earth as a thermal energy storage battery. So if we talk about thermal energy asset and we're talking about energy storage, which you're reading about in the paper all the time, or on your iPhone or whatever you're reading, that ground is a energy storage vehicle or battery, okay? And the ground is a renewable asset also. So in effect, this technology is a renewable thermal asset that actually stores energy from the ground. Next, please. I'm getting called, and I'm going to mention some things here because I get called a lot. I know everyone in New York is familiar with Dandelion. John Ciovacco was involved with it at one time. Amazon has reached out to me to get more info on their new offices and new headquarters being built. Ball State is 5,000 tons. There's 250 plus schools in Texas that are using geothermal heat pumps. Now, the interesting part about institutional work is that in the Northeast where we live, I live in Philadelphia, but in the Northeast, the average age of a school is 49 years old. Every single one of those schools have had computers put in those schools, but very few of them are space conditioned. We've just done one in Long Island where we took a 1957 school and used American Water's water to bring geothermal heat pumps into that building. Now, there's a necessity for this is that computers add interior load to the building. So you have a thermal load being added and nothing else being done to it. So now if you have 25 kids in a classroom that it was designed for, if you put 5 computers in there, you now have 30 bodies in there. So you've got an overheating that's happening. Typically, you're not going to open the windows because of outside conditions. This technology gives a comfort level that both heats and cools. Although space conditioning, I've got a high school that's in Fargo, North Dakota rather, that is using nothing but water to heat and cool that building. So this can be as a form to help our schools, help our children learn better. This technology is something that is a prime candidate to get that done. Next, please. This is the new Ford Research and Energy Center in Detroit is being done. They're putting geothermal heat pumps in that project. Next, please. Now, here's the interesting thing we talked about. I'm going to hit a few points that Scott brought out. About the training, I'm also on the board of directors of the International Ground Source Heat Pump Association. The training that Scott talked about was we have training for installers, for designers and architects, engineers, for inspectors, and for drillers. So that technology is available through New York Geo, which is the good part about New York is we have a very robust infrastructure in New York, which I'm using as a model all over the country. We've got the best of all worlds here. We have a governor and a legislator that are interested in renewable resources. We've got an organization like NYSERDA that has supported this technology since Governor Pataki was governor, and through Governor Cuomo is still an ardent supporter of this. And we have an organization that is sistered with the International Ground Source Heat Pump Association with New York Geo that not only supports the training and the development of the infrastructure, but also houses some of the best installers, designers, and drillers that in the United States. So the interesting part of this, and why when I'm speaking to legislators or senators, congressmen, the fact that this is renewable isn't something that really hits their hot button. But when I mention the fact that for every commercial application, 22 jobs are either created or retained, that really makes them sit up and listen, because legislators understand that one job in the course of your campaign may count for 15 votes. So if I get you a job, you'll probably get me 15 votes through the course of my career. That's what they're interested in. If we could grow this, right now we have less than 2% of the market. If we could grow this to 30% of the market, we would have to create or retain 5 million jobs. Now, this technology, like I said, next please. I'm using New York as a model for the rest of the country. Once again, utilities such as Con Ed and National Grid are exploring using geothermal heat pumps as a non-pipeline solution to manage the growth of peak demand, meet resource constraints, mitigate risk, and enhance system flexibility, all the while considering the overall cost impact to customers. So I see this, we're at the top of the hill and about to continue that really fast upsourcing of this technology. Once again, I want to thank NYSERDA. I want to thank Pat and her group. I think this type of webinar, although like I said, I'm seeing more and more interest being taken in this all over the country, and it's because of the work being done with organizations like this that is getting the word out and is going to keep this technology strong. There's my information there. Like I said, that phone number is on 24/7. My email's up, and if I could move New York to the other 49 states, this technology would be, we would have to continually train people, because this technology is the best technology that I've seen yet. Once again, I've been in this business for 30 years. You see a lot of things that catches your eye. This technology will catch your heart, because it really does do a lot of things, not only for the environment, but it helps the coming generations be able to breathe. So, Pat, once again, thanks very much. Thanks everybody for your time. It's been a pleasure. Any questions you need, I'll be here. So, Pat, it's on you.
Terrific, Jack. Thank you so much. Now, as we said, there'll be questions at the end. I know I have some questions about some of the intriguing things you said, Jack, but we will wait till the end. So I'm going to put you back on mute. Thank you. Great presentation. And over to you, John Ciovacco. How are you this fine day?
Unbelievable. How are you, Pat?
I'm very well, thank you.
You're holding it together. So thanks, Pat, and thanks for the introduction from Todd earlier. I always like to hear Scott's comments. NYSERDA and some of the other state organizations are doing lots for us, and Jack is endlessly interesting and entertaining. And when I first entered the industry in 2008, I saw Jack speak, and I saw 10 other speakers that day, and he's the only one that I remember. So good on you, Jack. So let's pop to the next slide. So my company is Aztech Geothermal. We're located in Ballston Spa in Saratoga County, and we have 3 mechanical engineers that run the company, and then we have installers and some administrative folks. So we're what I would consider a design-build company. We do mostly small systems, so lots of residential, single-family residential, some small commercial, and then we end up consulting on larger projects. We don't really participate in the design bid build world. We're more design build. But if there's trouble afoot at a larger system, we'll jump in or work with consult on the front end of it. So we're really interested in having this technology succeed because we know when it's designed and installed properly that it will succeed. You have to be, as an installer, you have to be reasonably good at incentives and financing options to make this an affordable technology for people. And it's a changing landscape, so it was good to have Scott review some of that earlier. And if anyone gets serious about it, you just need to dig in and talk to NYSERDA or talk to your installer and find out what's available specifically for your project from really a host of different angles right now. Let's go to the next slide. So when we approach the installation of a project, we first think about the building envelope, because a lot of times when we'll come in, and let's say it's an existing building, that building will have used a boiler or a furnace or some kind of combustion source for heat, and then it'll have air conditioning sometimes. But oftentimes it's we have to say to ourselves, I could install, let's say it's a single-family home, because that's kind of a repeating unit that people can understand. If I go into a home and it had a 100,000 BTU an hour furnace in there, well, 100,000 BTU an hour in our vernacular in the heat pump world is 10 tons. And 10 tons is a lot of heat pump. And if it's a ground source heat pump, it's a lot of ground loop to match up with that heat pump. So it's often good to think first, what could we do, or what could this building do to be tighter, to be better insulated? And oftentimes you'll hear the word building envelope. So how do we address the building envelope? Now, we participate in the Home Performance with Energy Star program and have BPI certifications and accreditations and things like that, which gives our sales and audit team the ability to go in and try to figure out where some of those problems are. Sometimes we address them directly in advance of designing a heat pump system for the building so that we can put a smaller heat pump in and get the job done. It's just a better use of money rather than put in a big expensive geothermal or air source heat pump system. Could we put a smaller one in and shift some of that money that we're saving on the smaller system into the building envelope? And there's incentives available for those things. I would say for our company, and I think it's true for a number of companies that specialize in the design and installation of heat pumps, we're not great at air sealing and insulating on a grand scale, but there are other contractors that are. And so we do a fair amount of referrals to other, say, BPI accredited contractors in the area that really specialize in that area. But we're very keen to trying to point that out. And any time that you look at putting a heat pump system into an existing building, it's worth considering. One of the reasons why it's particularly important, too, is that combustion air, let's say if we had a furnace and it's blowing hot air, and if it's natural gas or propane, you might have 120 degrees at the register. So with the air that you feel coming out of the wall into the room or out of the floor might be 120 degrees. If it's an oil system, it could be as high as 140 degrees. And if we put a heat pump system in that same building, we're more around the 90, 100 degrees. Now, can you get a room to 72 with 90-degree air? Sure you can. But the building envelope has a big effect on that. If the ductwork takes a long meandering route and maybe goes up external walls, that 90 isn't 90 anymore. And if we haven't really looked at the building envelope, sometimes we're not as successful as we could be as well. So that's the first thing that you should think about is before I convert to a heat pump is there something I should be doing to air seal, which is the most cost effective, and then insulate? Where can I strategically insulate to make this building a lower load building and put in the right size heat pump and have that heat pump feel nice and warm and successful in the winter and not have to dehumidify as much in the summertime. Next slide. So there's lots of different kinds of heat pumps and shapes and sizes. They all, mostly the ones that we'll talk about today, work on the same principle. It's really the same technology as your kitchen refrigerator or a window air conditioner. The majority of them are what are called package systems, where the heating and cooling element is all in the same box. Sometimes it's a split system. You'll hear something like mini split, where the hot part and the cold part are separate. They're split. One's outside and one's inside. And then if it's a heat pump, it reverses. So for instance, an air source heat pump, in the summertime, it runs like an air conditioner. The condenser, the hot part, is outside, and the cold part, the evaporator, is that unit on the wall inside. But then in the winter, the refrigeration will reverse, and the cold side will be outside, absorbing energy through the evaporator outside, but it's still that box outside with a fan in it. And then the inside part is the condenser. It's the hot part. So it really depends on your building, depends somewhat on your goals as to what the right application is. Most geothermal heat pumps, which are really just forms of water source heat pumps as well, they'll be inside the building entirely and then connected to a ground loop that comes into the building. So they don't have an outside component. And they mostly are reversible and heat and cool, and can send off either hot or chilled air, or if they're water-based systems called water-to-water, they will send out either warm or chilled water, depending on what the application is. There's also air source heat pump water heaters and some air source heat pumps that heat and cool water. Instead of a mini split system, which is in the center there, is something that we're heating or cooling air, and we're using the air outside to facilitate that. But you can also have some air source systems that are heating and cooling water. So that on the top right-hand side there, that's an air-to-water heat pump. So that's taking thermal energy from the air in the winter and compressing it and then making water warm, and might feed a radiant floor or something like that. Some people might have seen, or maybe even have, an air source heat pump water heater, where you've got essentially the same kind of mechanism that you'll see on a home dehumidifier, but it's right on top of that water tank. And so instead of, and it does actually do a little dehumidification, but it's really there to take thermal energy from the basement or the mechanical room, wherever the unit is, make that warmer and put it right in there. And that can be a more efficient way. It usually is about half the amount of electricity to heat water as if you just had an electric water heater. I'll talk about later as to whether some of these different applications, where they are cost effective. And it's really relative to your source of energy and the price of that energy as to where some of these different applications are a better fit. Next slide. So that we just talked about heat pumps and the fact that they can make warm or cold air or warm or cold water. They tend to do it, again, at lower temperatures than furnaces and boilers, say in the heating, in which case the distribution system needs to be looked at pretty carefully to make sure that we can deliver the amount of energy to make a room comfortable. So you can distribute through hot water baseboard, but it's oftentimes, as shown in that picture, one that might have a higher surface area. So a lower temperature water can make the room comfortable. Most boilers will send 160 to 180 are the most common temperatures a boiler will send out to that hot water baseboard system. But a heat pump is not comfortable making water at that temperature. We're more 120. We're happier at and more efficient at 100. So if we have more surface area, we can make 100 or 120 do what 160 does, but we need more surface area to do it. There's radiant panels. There's ductless systems like the ductless mini split too, but you could also send water to certain types of ductless systems. So you could heat or cool water with a heat pump, and then you could send it to a head unit like that that might be controlled with a remote, as shown. Radiant floors are always an interesting mix with heat pumps because they have such an enormous surface area. It's the whole surface of the floor, as long as we don't put too many carpets and things on it. But we can run lower temperature water to those. And then a central ductwork system is super common in this area, less common in other parts of the world, but common around here. And I would say that on retrofits, we fit into existing ductwork and sometimes need to make slight modifications, but for the most part, we can get it to work. And then there's other times where somebody has hot water baseboard, or they have some other system that does not have ductwork, but they want air conditioning anyway. So as part of the installation, we might install a new set of ductwork that will heat and cool the house because they wanted air conditioning anyway. Because that's one of the bonuses of heat pump systems, is that they have the ability to both heat and cool from the same unit. So if you want often the economic benefits are on the heating side, but a lot of comfort certainly can come from that air conditioning side. Next slide. So now we get into some of the technical stuff. Right here is just a quick kind of schematic of how the efficiencies work. Oftentimes you hear with heat pumps that they'll have 200% efficiency, 300% efficiency, 400 or more % efficiency. What does that mean? Because that seems kind of odd. And I guess officially, can anything really be over 100% efficiency? But let's suspend that, any suspicion you have about that for a second, and I'll just explain why that's true. If you see on the left side of the slide, we have Q1 is a source of energy. That source of energy could be the air, it could be the ground, it could be water that's circulating in a ground loop in the ground, and if it's in heating mode, it goes across the evaporator and causes the refrigerant to go to a vapor. The compressor, really all the compressor does is make vapor hotter. If you compress a gas, it gets hotter. So the electricity that we're paying for in a heat pump is really just there to compress the gas to make it hotter. Why do we make it hotter? We make it hotter because we might need to heat the building, or we make it hotter because we're trying to get heat out of a building and we're trying to get the outside air to accept that heat, and it will only accept it if it's hotter. So the compressor is always just making that gas hotter and leveraging the energy that comes out of the ground or the air. Because if it's a ground source system, and let's say the ground is 50 degrees, 50 degrees is a great temperature, but it's really not warm enough to heat the house. Nobody really sets their thermostat at 50 if they're living there. That's kind of chilly. So we can take 50-degree energy, though, we can get that into the evaporator, we can get it into the vapor, and then the vapor, when it's compressed, will go up to 160. Now, 160 is starting to sound like a temperature we can do something with. So the red side over there, after the compressor, is the condenser side. That's the hot side. And then we're going to either blow air or water will go over that. We'll either heat water or heat air. And you'll see the arrows. We've got that Q1 arrow is the energy from, say, the ground. The Q2 arrow is the energy that's given by the compressor, by the electricity that we purchase oftentimes. And then the output is that Q3. And then you'll see the quick little schematic math there. Q1 plus Q2 equals Q3. So the output, what we get into the house, is much greater than what we pay for. We pay for Q2, but that Q1 is oftentimes bigger. For a ground source system, it's usually something like Q1 is, say, 3, Q2 is 1, and the Q3 would equal 4. That would be a COP, or a coefficient of performance of 4, which could be interpreted as 400%. Air source systems, it tends to be about half and half. So if I'm heating a house with electric baseboard, so I'm just using those kilowatts and kilowatt hours just to make heat with a resistance coil, then there's not a lot of additional leveraged efficiency in that. I'm just using the electricity directly to make heat. But if I use that electricity to compress the outside air temperature, the energy that's outside, then I get a factor of 2. So the Q1 in this case would be the same size as Q2, and Q3 would be twice the size. So that's a 200% efficiency. Now, all of those efficiencies sound awesome when compared to the efficiencies, say, of a boiler, but it really has a lot to do with how much does energy cost. And we'll go through some of that a little later as to how the economics work. Next slide. I've made mention of it a couple of times. This is a ground source on a larger commercial building. So we're circulating water in the ground, and it always goes in the same direction. We're just trying to get thermal energy to come into the building, or we're taking thermal energy in the summertime out of the building and putting it into the ground. and that's where our thermal exchange is happening. The heat pumps themselves actually, they'll reverse. So we have that thermal exchange running. The refrigeration cycle actually goes in a different direction, and what was the part of the unit that was heating is now the cooling part, and the part that was cooling is now heating. And it's again to leverage that energy to get it to move in a direction where it wouldn't normally go, and to use as little electrical energy as we can or we need to get the result that we want. But that reversible element is a real advantage, and I would say especially in ground source, where we've got, if you need air conditioning in a building, residential or commercial anyway, the air conditioning system is essentially the same technology as a heat pump. So if you had to buy an air conditioner anyway, you have less equipment. You basically have a piece of equipment that's doing double duty. It's both heating and air conditioning. And these are sealed refrigeration systems, and once they're all set up, they'll run for ground source, will run in the order of 25 years. And air source, depending on how it's taken care of, it's probably in the 15-year range. If it wasn't set up well, less. If it's really taken care of and in a good spot, could be more. Next slide. I'm just going to show a couple of examples of heat pump technology. Very popular right now is the ductless mini split, and you'll see just the condenser in this case is outside, the evaporator is on the inside. That's an air conditioning mode, just like a regular air conditioner. And really the difference is with a mini split versus just an air conditioner is that those will reverse. And so the evaporator is shown on the inside in air conditioning mode, condenser outside as shown. But you just switch those words if you were in heating mode, if you were taking thermal energy from outside and heating to the inside. So the condenser would be now the inside. But all of that happens in not anything that you have to touch. It's really just a setting to go from heating mode to cooling mode, and it reverses itself. You can even set these systems to automatic changeover for ground source and for air source, where they'll just switch from heating to air conditioning. So if I want to keep my house at 72 degrees, or I keep my building at 72 degrees, I just need to set it at a temperature, and then it'll either heat or air condition, depending on what it needs to do from that single unit. Some of the ductless mini split technology can go down to negative 13 degrees, or you even hear negative 20, and they can continue to run as a system outside at super low temperatures, some of them, but their efficiencies really struggle pretty badly at that point. So just because it can run doesn't mean that it's really saving you any money or that it's at all efficient. One of the downsides of air source systems can be that if it's cold and snowy and icy, they decrease rather dramatically in efficiency, and then even can have trouble with, you have to think about, do I have to get the snow out from around it, or do I have to worry about it getting iced up? So they can work well in certain instances and with the right care and the right placement, but they're not quite as user-friendly as a ground source system, which everything is inside the building and there's no exposed technology. Next slide. So a variant of the ductless mini split that you kind of see, where you might have one or you might have up to 4 or 5 head units somewhere, say in a residential or small commercial building, is a much larger system called a variable refrigerant flow or variable refrigerant volume systems that different manufacturers have come out with. And those can have 40 off a single condenser unit, like that one that's shown below in the bottom picture. That unit right there is a ground source-based unit or a water source-based unit, so that's not outside. That would be something that would be inside the building. And then that would send either hot or cool refrigerant out to different heads and different locations in the building. And there could be as many as 40. I think even one unit can distribute out to maybe 60 different locations. So in a larger commercial building, there are interesting retrofit applications. And you'll see in the picture above that there's an air source unit version of it as well. So the distribution system is through refrigerant. So instead of channeling water to all these different locations, you basically have smaller refrigerant lines that go to each of those, and then each individual space or room could be heating or cooling, and some of that can happen simultaneously. And in the picture you'll see in the back rooms there, you'll see the red coming out of the units. That means they're in heating mode, and they might be, say, in an office area, and then the others are in cooling mode. So from a single unit, you could be heating and cooling at the same time. It's kind of a neat technology, and it can be done as a water source or ground source system, or it could be done as an air source system, depending on economics and your goals and things like that. But it's a larger building conversion technology for heat pumps. Next slide. Ground source heat pumps have indoor units. Again, those indoor units could either be blowing warm or cool air, or they could be heating water or sending chilled water out for air conditioning. But the outside system, you have some options in terms of how you might do it. And so we could bury pipes horizontally. In this area, if we go just about 6 feet down over a large area, we can get enough thermal energy out of the system to make that work really well, and then we'll deposit that energy in again in the summertime. Vertical systems save you space. They don't really look like that cartoony picture there. They tend to be 6-inch borehole, where we're going to go straight down and generally hundreds of feet. A common single-family residence might have one 450-foot borehole, or one 500-foot borehole would be kind of common numbers that we see. And a 500-foot borehole is about a 50-story building if you looked up and just think. So it's really quite deep in the ground, and that's so we can access thermal energy, but without taking up a lot of space that we need for the house. You can put loops in ponds, so polyethylene piping, and we circulate the water in that piping that's at the bottom of the pond. And even when a pond freezes over, we can still get thermal energy from the bottom of that pond, unbelievably enough. There's also a technology called direct exchange, where the refrigerant actually from the heat pump itself goes into copper pipes that are in the ground, and they facilitate the thermal exchange. So the other three use plastic pipe, and they have a water-based solution that circulates through to get the thermal exchange. The direct exchange uses the refrigerant actually that's in the heat pump itself. And time doesn't really allow to go into a lot of detail on those, but there's different ways to do it depending on how much space that you have and what seems to be the best economics, and the site location has a lot to do with it as well as to which of those loop configurations we might choose. Next slide. So always interesting, and I have my assumptions here, and the assumptions change all the time. So propane probably isn't $3.08 a gallon right now, and natural gas can be $1 a therm, or it could be less. So there's certain assumptions that will drive these relativities, but given those assumptions, we see that geothermal and natural gas are pretty close. So when you're heating, and the cost of heating is about equal. So about equal is pretty great, because natural gas is very inexpensive, but it also doesn't produce much savings when we go up against natural gas systems. So that's something to consider if you're making recommendations, or you're thinking about it for your house or for a commercial building. Air source heat pumps kind of really fall out of the realm of, they actually cost quite a bit more to operate in heating mode than natural gas or geothermal. And from an air conditioning standpoint, they're very similar to a regular air conditioner, because they're dumping that thermal energy from the building out into the hot air, just like an air conditioner is doing. You have some part load efficiencies with some of the variable speed heat pumps that are out right now, but at peak, they definitely don't give you a big advantage. But an air source heat pump, depending on the price of oil or propane, can produce some savings for sure. So if you don't have access to natural gas, then heat pumps look pretty great. Air source and ground source can show savings in terms of heating. Electric baseboard, or opening your oven, or turning on lots of toasters or hair dryers, that's not so good. And that's really just a function of the ratios we talked about earlier. If I'm just using electricity to make heat directly, even though it may be, and it actually is 100% efficient, but it's with an expensive source, and it's not a cost-effective thing to do. Geothermal might be 25% of the cost of an electric baseboard system, and an air source system might be about half as much. So if someone has electric baseboard to heat a building, then air source or ground source are an immediate step in the right direction. Next slide. This is a super important concept, and again, assumptions shown. So this has nothing to do with money. This is just about pounds of CO2 per therm, the same, just a common unit of measure, 100,000 BTUs, how much carbon might get released. And so whenever you have dissimilar technologies, how do you come to those numbers? There's a certain assumption about how much, what's the carbon impact of a kilowatt hour of the electricity that's out on the grid, because some of it is produced with fossil fuels, and then we have distribution losses and things like that. So that's why geothermal and air source heat pumps are showing any carbon footprint, is because we're assuming they purchase grid electricity, and that grid electricity has a carbon footprint associated with it. But on site, they're not burning any fuels at all. Natural gas burnt on site, propane, oil, and then electric there too is that assumption of the grid impact on it. Now, if we want to achieve net zero, let's say that we have enough renewable electricity that offsets it, then if we have a renewable source of electricity, then the air source or the ground source could be zero. So we can zero out the carbon impact because we don't have any on-site emissions, and if the electricity that we're getting we can claim as very clean, then the impact goes down. There's no amount of renewable electricity that gets the natural gas, propane, or oil down to any extent at all. So when we're looking at carbon reduction, these technologies are certainly very important. And New York has a very clean grid, so we tend to do very well versus fossil fuel technologies. Next slide. So one of the things that some of you might be interested in is that we have the biggest Northeast regional conference for ground source heat pump technology anyway, for the geothermal technology. It happens right in this area. It's NYGEO, which is the New York Geothermal Energy Organization. We have our 2019 conference coming up in April 10th and 11th, as you see there. It's at the Rivers Casino in Schenectady. So if you're a heavy gambler, then it might be great, or maybe you need to stay away. But we'll be there, and I know Jack will be there too, and Scott. So we'd love to have you there, and there's all kinds of great information that gets exchanged at conferences like that. Next slide, which is the last slide. So that's a system that we put in a home. That's a 12-speed or variable speed heat pump with a variable speed flow center, which is that black box in the middle with a circulator on it. And then there's a 2-tank desuperheater, so we're assisting with hot water. So one of those tanks is a preheat tank that the geothermal system heats, and the other is an electric tank that finishes it off. So it usually just needs to get the water from, say, 90 degrees to 120. So it's a big savings in electricity for hot water as well. That's me.
Hey, John, thank you so much. I really appreciate it. Let's see. Just going to take a look at the chat box here. Okay. So I have some questions, and I know some people in the room here might have one or two. Oh, here they are. For a lot of us who are on this call listening to these excellent presentations, we remember back in the early 2000s when NYSERDA was first incentivizing geothermal. And some really great things came out of those years. A number of colleges, for example, went fully geothermal. By the way, I'm not sure who should answer this question, but we could figure that out. However, there were a lot of entrants into the marketplace as geothermal installers, and as with most things, you know, there had to be kind of a shakeout. So I do remember things like Bard College becoming entirely geothermal over a period of years. And I also remember some municipalities going with geothermal, but then having some issues, probably directly related to installers' experience and expertise. So I wonder, for this audience that is reacquainting itself with geothermal, the technology, and the issues around it, can someone address the question of, what has changed in the intervening years in terms of quality? The issue that used to come up was oversizing, just to give you a window into what I'm remembering. Can you comment, perhaps, Jack could kick us off. I have to unmute everybody, about what has happened in the industry in terms of, expertise and installer knowledge. It's always been, an extremely attractive technology to many institutional users, but, with some challenges. What do you think, Jack?
Yep. Yeah, actually, Pat, I was involved in in those projects. We actually did 115 projects that was sponsored by the Geothermal Heat Pump Consortium. What has changed? There's a number of things have changed. Back then, we didn't have any standard. Now, if you're going to participate in any of these programs, you have to carry IGPA certifications, which gives you a modicum of insurance that they've at least gone to some classes. The second thing is, in New York, we didn't have New York Geo. And New York Geo, and like I said, I keep saying this, and even though I'm very well connected with New York Geo as one of the founding members, but New York Geo is probably one of the biggest assets that New York has, because it's a compendium of people like John that are experts in the field. And the interesting part about this, and Pat, going back to your remembrance, what's interesting about this technology is, if I blow up your house tomorrow with gas, they go, it's too bad Pat's house blew up, but we'll put gas back in it when they rebuild it. If your house doesn't work in geothermal, it doesn't work in New York. So that's the difference that we're all very, very familiar with. And we work very actively, both in IGPA, in my organization, and in New York Geo, and across the nation, in trying to make utilities, legislators, governments recognize that there is a standard of training that someone should have completed. And even completing that, we've learned that you also have to ask for a resume or recommendations. So the problem when any state or utility wants to go into geo is everybody becomes an expert. Back in the old days, and I hate to say that, but it was back in the 2000s, no one put in the codicil that you had to carry IGPA credentials. The training that Scott mentioned, that was mostly IGPA training to develop that robust infrastructure that can support it. So New York is probably one of the best infrastructures of any state in the union, for geothermal. And once again, now that when we're going into these questions or into these projects, there is a hurdle that everyone has to cross. That is, you better be carrying, some sort of credential.
Right. Thank you. And John, you have a comment?
Yeah, just the NYSERDA program, I'd said this for years, but it just took a while to happen, and it's terrific that is happening, is that we have an incentive program that's very attractive, and everybody that participates would like to have those incentives from NYSERDA, but they come with criteria now. And my company has always had a very strict criteria on how we do things, but that's been pretty independent. And working with NYSERDA to develop a criteria for what is a good installation has really been helpful to my company, and very helpful in terms of not having a rash of poor installations, because they have a quality control and quality assurance programs. Just today, we have 2 of our installations are being inspected by a quality insurance inspector that is under NYSERDA's guide. and we're going out there with them, and we're going to go through it, and that never happened before. And we really welcome that kind of interaction. It certainly puts us in a dialogue where we up our game, and just establishing the criteria with NYSERDA was a good exercise for our industry, and it's a real barrier to people that don't know what they're doing because they can't meet that criteria. But at the same time, that's just what's needed to protect the public and to have good installations, and ultimately our companies will be more successful with those good installations. So it's really been a great partnership with NYSERDA.
Oh, that sounds fantastic. Thank you both.
Yeah, thanks a lot,
Jack,
guys.
Jack, while we have you, you mentioned quickly that everyone knows what dandelion is, but as you would say, I might take issue with that. So do you want to just fill us?
Sure.
You want to just fill us in a little bit about dandelion, and if the Rhinebeck case study is appropriate, maybe you could say something about that.
John probably was better qualified for that, but Dandelion is a company organization that was actually started by Google, and their mission is to try and lower the cost of the installation of a geothermal residential heat pump system. And once again, it shows that the reason why I mentioned Dandelion is because prior to that happening, if anybody gets Google alerts, geothermal would be mentioned about every third month. Right now, they're talking about geothermal practically 3 or 4 times a week. That's what's interesting about Dandelion. I can't address how well they're doing or the Rhinebeck, but I think John can. John, were you involved with that?
I was not all that involved in it, but I do know that that they were given an easement essentially to install ground loops on the utility area along the road as a gateway to being able to convert entire communities. So it's really an interesting and evolving development and relates, I think, pretty closely to some of the comments that Jack had earlier.
Mm-hmm.
Pat, just so you know, National Grid did the same thing in Long Island. They developed a for a number of houses there. We put in a ground loop, and that's a pilot program for National Grid. I know Con Ed is looking at this technology also. Once again, utilities are looking at new business models, and I think this technology fits that. And that would help our industry quite a bit, because if a utility owned that ground loop, then it would take that first cost out and would benefit everyone, including institutional work.
Right. Okay. Thank you. I have a question here for Scott. Scott, can you talk about some of the projects that the current clean heating and cooling campaigns are working on?
Sure. If this came through the chat, it might be difficult to clarify. I heard the word campaigns, and so I think maybe the question is referring to the clean heating and cooling community campaigns that I talked about.
I think so. Yes. Sorry.
Yeah. So they're all doing something very similar, and we're in the process of helping them get launched right now. I think this morning. There was a nice little segment on the local NPR station in Syracuse about the Heat Smart CNY campaign. We actually don't have any projects. If the question is about specific projects that have been done, because we haven't, the campaigns are in the process, most of them getting launched. I can't talk about specific projects yet. But Heat Smart Tompkins, which is what the concept is that we're rolling out statewide, is pretty much based on. Just is in the process right now of closing down their third campaign, and and I don't think I can quote all the statistics from the second campaign off the top of my head, but from the first campaign, they had 300 customers enroll, and about 100 of them did projects. Nearly 2/3 of those did energy efficiency projects. About 36, I think, or so did air source heat pumps, and about 13 or 14 did ground source heat pumps.
Mm-hmm. Okay.
Hopefully that's responsive to the question.
Yes, thank you. I have another one here for, I guess, anybody from Abby. When the thermal source is from a pond, can the pond still sustain fish?
Yes. That's it.
Okay.
This is Jack. Yes, it can. All this does is it's just taking or BTUs out of that water, and it doesn't affect, at least the ones that we've never had an issue with wildlife, whether it be fish or shellfish or anything else. And the new system that was just put in Nashville Airport is a Slim Jim, is a pond loop doing that whole airport.
Mm-hmm. Fascinating.
Okay. I have a quick comment about that as well. So we have we probably have 12 or 14 pond loop systems that are tied to single family homes. We have to make sure that the pond has enough surface area and has enough depth that the ground loop won't have any measurable impact. But all of those ponds have an ecosystem that is unaffected, and we have lots of references for that locally, and understand how those operate quite well.
The depth in the area is the big thing.
Okay. I think this is a Scott question. Are you doing specific work to make local governments aware of the technology for their buildings? Can they receive the incentives that have been outlined here today? And do you have any adopters you can talk about? Any early adopters in this campaign?
I'm going to take them slightly out of order. So yes, municipalities are eligible to receive the ground source heat pump rebate. As I mentioned previously, the air source heat pump incentive is only for residential and multifamily. We're probably going to be launching something for air source heat pump systems, typically referred to as variable refrigerant flow systems, that are more suitable for larger buildings sometime next year. We are working with our clean energy communities team, that this group is actually sort of supporting, to try to do a better job of getting the word out. Municipal campuses or municipal groups of buildings were eligible for that geothermal clean energy challenge, so that was one way that we were able to kind of get the word out. I don't know. I can't speak to the list of 20 that are moving forward, whether any of those are municipalities or not. I know a number of them are college campuses, but I don't know if any of them are municipalities. And I have to say, I don't think I can name a municipal building. I know that there are municipal buildings, but I don't think I could name one off the top of my head that have recently done heat pumps. I don't know, John or Jack, do you know of any specific municipalities?
I think there was a fire station or police station that was in, and I don't even know what municipality. But the one thing that you have to recognize is that the municipals or college campuses or any institutional buildings, if they're nonprofit, can't get the federal tax credit, investment tax credit.
Sure. Right. Yep. Okay. Well, that makes us just out of time. I want to thank everyone so much for their participation. This has been truly informative, and I know it's been a real catch-up opportunity for a number of our attendees who, may have known about the geothermal programs of before, but this is wonderful now that we have the new ones. So thank you all very much, and see you next time on a CDRPC webinar.
Pat, one last thing. I would say if people have asked questions that you want to send out to Scott, myself, or John, I'm sure any of us would be glad to answer them.
Oh, that's
Absolutely.
great, Jeff. Thank you
Thanks,
so
Jeff.
much. Yeah.
Thanks, everybody.
All right. Thank
All
you,
right.
everyone, for coming to our webinar.
Bye-bye.
Thank you.
Bye-bye. Bye-bye.